Welcome back to this online training series. In this session, the focus is on the optimal creation of data objects for effective use within Legos. The session provides a practical demonstration of the data object creation process and introduces the key concepts required to build efficient and effective data objects. By the end of this session, a clear understanding will be established of how to maximize the value of data objects within the platform. In support of faster response times and improved platform performance, Intenda has developed a recommended approach to data object creation within Legos. By following the guidelines presented in this session, the Frax's platform's data processing capabilities and overall user experience can be significantly enhanced. Before exploring best practices, it is important to understand the role of data objects within Legos. Data objects are the fundamental units of data within the system, encapsulating data and operations that can be applied across multiple data sources. They serve as the foundation for organizing and processing information across a wide range of use cases, including write-back services, API endpoints, analytics, reporting, and ETL processes. The importance of optimal data object configuration cannot be overstated. Data objects often rely on large, remote datasets, and inefficient design can result in significantly slower response times and reduced platform performance. Performance optimization is a shared responsibility across all Legos users. To maximize system efficiency and minimize the risk of poor performance, all team members involved in data object development should contribute to ensuring that data objects are designed and configured optimally. Efficient data processing is central to Legos' ability to provide a seamless user experience. By understanding the purpose of data objects, recognizing the importance of optimal configuration, and embracing a shared responsibility for performance, organizations can significantly enhance their data processing capabilities. When discussing response times and platform performance, the quality of data object design plays a critical role. Success depends on understanding the underlying data, its intended purpose, and the relationships that exist within it. Before creating data objects, it is important to understand the business requirement they are intended to fulfill. A clear understanding of how the data will be used, where it resides, and how it relates to other data forms the foundation of effective data object design. Intenda recommends a layered approach to data object development. The process begins with the creation of base data objects that form the foundation of the overall data structure. These base data objects should accurately represent the underlying source data and include all entities required to meet the business requirement. Particular attention should be paid to attribute names, data types, and any required transformations. Where appropriate, push-down processing should be enabled on these objects. This allows queries to be executed directly against the source system and can significantly improve response times. Base data objects establish the foundation for all subsequent transformations and operations. By ensuring their accuracy and completeness, a stable and reliable data framework is created for future development. Once the base data objects have been created, the relevant owners should verify that they accurately represent the underlying data and satisfy the required business needs. Following successful verification, the objects can be published and utilized within other data objects. Caching should also be considered as part of the overall design strategy. As a best practice, base data objects should be cached when working with large datasets. This allows data to be queried directly from the compute infrastructure, reducing dependency on network connectivity and improving performance. Two caching approaches are available: manual caching and scheduled caching. With manual caching, periodic refreshes must be performed to ensure that the data remains current. Scheduled caching automates this process and ensures that data is refreshed at defined intervals without manual intervention. For large datasets containing unique identifiers, scheduled delta caching is strongly recommended. This approach caches only the data that has changed since the previous refresh, reducing processing overhead while maintaining data currency. Once a reliable data baseline has been established, base data objects can be used to construct federated data views across multiple business and hierarchical levels. Where federated views are built from cached data objects residing on the same data source, queries are executed directly against the cached datasets, resulting in significantly improved response times. When working exclusively with cached data objects, push-down processing should be disabled. This ensures that queries are executed against the Spark cached datasets, delivering optimal performance. The ability to join tables, transform data from multiple sources, and create data objects that span different business levels is one of the key strengths of the Frax's platform. These capabilities provide Legos users with extensive flexibility when designing data solutions. The key to successful data object creation lies in a hierarchical approach, ensuring that each level of data objects is designed to satisfy the requirements of the levels above it. This can be thought of as building a pyramid, where each level depends on the foundation established by the level beneath it. By constructing data objects methodically, one level at a time, federated data views can be developed that are both robust and comprehensive. An important advantage of this approach is that additional fields can always be introduced at a later stage. Rather than being constrained by a rigid structure, Legos provides the flexibility to adapt and evolve data objects as business requirements change. Creating data objects that deliver the required business views for different applications may involve multiple levels of the data hierarchy and the processing of substantial volumes of data. Effective caching becomes increasingly important as data volumes grow. By caching data objects that are ready for consumption, rapid access to critical datasets can be provided to downstream applications and services. This is particularly important when data objects combine data from multiple data sources. A well-planned caching strategy helps minimize latency and ensures consistent access to information regardless of its origin. In summary, successful data object design requires careful planning, a thorough understanding of the underlying data, and a strong focus on performance optimization. By applying appropriate caching strategies and following a structured development approach, data objects can be designed to deliver fast, scalable, and reliable access to information. Data objects represent powerful data transformation tools within Legos. When designed effectively, they streamline data processes and enable rapid, dependable access to information across the organization. Ultimately, well-designed data objects allow organizations to maximize the capabilities of the Fraxsys platform and deliver the best possible user experience. Thank you for watching this video. In Part 2, these concepts will be demonstrated in practice through the creation and optimization of data objects within Legos.